Okay, we're here at the beginning of chapter 5, and working through 5.1 here. I may lower this down a little bit before I get to the three variable. I want to solve a linear system first. So, in two variables, which means there's two variables here. In this case, x and y. We're going to make it simpler here. The idea, there's other ways of solving this. There's variations, but I'm going to go with what's called the elimination method. That's the right here. I'm going to try to cancel one of the variables, either the x or the y. In this case, I'm going to try to cancel x. So noticing that if I multiply x by positive or negative x by positive 3, this becomes negative 3x. Added to a positive 3x will cancel. So that's what I went ahead and did here. I distributed by the 3. Negative 3x plus 3y equals to 9. Noticing by design, the x's cancel. 3x minus 3x is 0. So 2y plus 3y is 5y. 11 plus 9 is 20. So 5y equals to 20. I divide both sides by 5. And so now y equals 20 divided by 5, or just 4. Then I plug in 4 into one of these two equations. I chose the second one. And so negative x plus 4 equals to 3. Subtract 4 from both sides. So x equals negative 1. Negative x equals negative 1. And I divided both sides by negative 1. And I know it's so smaller, but I kind of ran out of space. So that x equals positive 1 here. So now I have the y value and the x value. So the solution is an ordered pair. So the answer is 1 for x, 4 for y. And that's essentially how you solve a linear system using what's called the elimination method. Eliminate a variable, take one of their answer, and substitute it back in. So it's actually called elimination. So now three variable is a little bit different. So in three variables, you use what's called Gauss elimination. It's essentially an elimination, but as we did here, we're going to substitute back. Except because there's three variables, we have to solve a more detailed, more steps. So it's going to be an extension of this problem. So in three variables, you use the Gauss elimination with back substitution. There are many variations of this elimination. I'm going to stick to the same one. I'm going to show you the same process throughout. This could vary. There's many variations of this. I'm going to show you the same type of variation every single time to not confuse anyone. So you have the equation x plus 3y plus 2z equals to 1, 2x plus y minus z equals to 2, x plus y plus z equals to 2. Here, excuse me, this is the first equation, this is the second equation, this is the third equation. Now there are certain rules. You can swap the order of equations. If you want the first equation to be the second one, or the third to be the first, or the second to be the third, you can reorder them if you want. I'm not gonna do that any of that. Secondly, like here, you can multiply any number you want to any equation you want, with the exception of 0. You can't choose a 0 to multiply. Any other real number would be okay. Thirdly, you can add two equations together, as we did here, to cancel things out if you want. So those are the three rules essentially that we're going to use. So the way I'm going to teach it is this little steps right here. I'm going to take the first equation with the second equation, and I'm going to cancel this x. Then I'm going to take the first equation with the third equation, and I'm going to cancel this x. Then I'm going to combine the two equations that survive, and I'm going to cancel this y on the third equation. And that's going to leave me with a z answer. I'm going to take the z answer, solve for z. I'm going to take the z answer, and I'm going to plug it into the second equation once this is fixed. Then I'm going to get the y answer. Once I get y and x, I'm going to go back to the original first equation and solve for x. Once I get y and z, I'm going to plug it into the first equation, substitute it back to the first equation, and I'm going to solve for x, if this allows me to. So let's take a look at this. Everything's kind of worked out, so I can kind of show you step by step what I did here. So let me see, zoom in a little bit better. All right. Here's my original equation, my original three equation. So if I put 1 with 2, that's what it says right here. Equation 1 with equation 2 in such a way where x will cancel, I'm going to multiply the first equation by negative 2 so I can cancel with the positive 2. So that's what I did here. So negative 2 times the whole first equation. So negative 2x, negative 6y, negative 4z. Again, multiplying negative 2 times all of this equals negative 2. Adding up the x's or canceling the x's, adding the y's and the z's and the numbers, negative 5y minus 5z equals to 0. So that becomes my new second equation. Okay, so that was me putting equation 1 with equation 2. My next step is I'm going to put equation 1 with equation 3. This one with this one. And I'm going to try to cancel the x. So it doesn't really matter which one, since they're both x's, one of them has to be the opposite sign of the other. So I'm going to multiply the first equation by negative 1. And I'm going to hopefully cancel x. So when you multiply the first equation by negative 1, it basically changes their signs. And then by design, I cancel the x's. And so I have negative 3y plus y is negative 2y. Negative 2z plus z is negative z. That should be a z there. Well, not in the video. I like to put a little line through it if I can. So minus z equals to 1. That becomes my new third equation. So I have the new second and the new third. So I'm going to combine the new second and the new third, and I'm going to cancel y. I'm going to cancel this y with this one. So knowing that they don't really have anything in common, if I multiply 2 times 5 and 5 times 2, I get them both to be 10 or negative 10. So one of them has to be a negative number. So if I multiply the first equation by negative 2, I get that to be a positive 10. If I multiply the last equation, the third equation, by 5, I get negative 10. So the whole thing is to get these numbers to multiply be the same number and where they can cancel. So basically you multiply one by the other if you have to. But I pick an opposite sign because they're the same signs here. So negative 2 times the first equation becomes 10y plus 10z equals to 0. 5 times this equation becomes negative 10y minus 5z equals to 5. The y's cancel. I have 10z minus 5z is 5z. 0 plus 5 is 5. So then I divide both sides by 5 and get z by itself. So z is 1. So I solve for z. Then I'm going to substitute z back into the second equation, the new second equation, which was this one. So I'm going to take the 1 and I'm going to plug it right here for z. So that 1 goes in z's spot. So negative 5y minus 5 times 1 is 0. This becomes negative 5y minus 5. Then plus 5 to both sides, cancel the 5s. And then negative 5y equals to 5. Divide both sides by negative 5. Y equals negative 1. Then I'm going to take these two answers and I'm going to plug them both into the original first one. Again, the original first one being all the way up here, so I want to put a big arrow. So I'm going to take these two answers and I'm going to go back all the way to the first one. In fact, you can go to any one of these three that you want. I just have a tendency to go back to the first one. So z is 1, y is negative 1. Plug them here. Negative 3 plus 2 is negative 1, plus 1, both sides, x is 2. So the whole point is to try to get your x and y and z values. So 2, negative 1 and 1, x followed by y followed by z, called an ordered triple. So again, equation 1 and 2 kill x. Equation 1 and 3 kill x. Equation 2 and 3 kill y. Solve for z. Z back to 2, get y. Y back to 1. So let me do a little faster. 1 with 2, 1 with 3, 2 with 3. The third answer, 3, back to the second equation, 2. Second answer, back to the first. So a little faster. 1 with 2, 1 with 3, 2 with 3, 3 to 2, 2 to 1. And that's how this works. Let's try another one. Got a couple here. I'll walk you through this. So this is my system. The problems that you see here. Sometimes the numbers get big, sometimes they get small. It just depends. So I'm going to do 1 with 2 again. 3 and the 5, they both divide into 15. So I multiplied 5 times 3 and 3 times 5. But one of them had to be opposite signs, so that one of them is a negative 15 and one of them is a positive 15. So I multiply the first equation by negative 5, the second equation by positive 3. When I multiply the first equation by negative 5, I get these 4 answers. When I multiply positive 3 times all of these 4 numbers, these 4 terms, I get these 4 numbers. The x's cancel. When I add negative 10 plus 24, I get 14. Negative 5 plus 12, I get 7z. And negative 900 plus 1320, I get 420. Then I did 1 with 3. So I have 3 and 4. They got nothing really in common, so I multiplied one to the other and vice versa, except one of them had to be a negative number. Doesn't really matter if it's a negative 4 and a positive 3 or a positive 4 and a negative 3. You're going to ultimately get to the same result at the end. So multiplying by positive 4 and multiplying by negative 3, I get this result. The x's cancel. 8y minus 6y is 2y. 4y minus 9z is negative 5z. And then 720 minus 840 is negative 120. So I have my new 2 and 3. This one is a 2, and this is a 14. Now I'm going to try to cancel y. So I noticed that if I multiply 2 times a negative 7, I get negative 14, which will cancel with a positive 14. So that's what I did. I multiplied this new second equation by negative 7. I took the first equation, put them right there with them. So when I multiply the second equation by negative 7, I get this result, negative 14y plus 35z equals 840. I cancel the y's. 7 plus 35 is 42z. 840 plus 420 is 1260. Then divide by 42, you get 30 as an answer. So 30, I'm going to put it back to the second equation for z. I'm going to plug in the 30 here, and it's going to put it here. So that's going to be 210. Then subtract both sides. So 14y equals 210. Divide both sides by 14. So y is 15. So I'm going to take these two answers, and I'm going to go back up to the first one. That's what this arrow is. Here is the work for that. Y is 15. Z is 30. 30 plus, again, 2 times 15 is 30. So 30 plus 30 is 60. Then move the 60 by subtraction, and then divide both sides by 3. So x is 40. So my answer is x first, then y, then z. And essentially, that's how you attack this problem. 1 with 2, 1 with 3, 2 with 3, 3 back to 2, 2 back to 1. Okay. So this is an example with an answer with a problem with no answer. So doing the same thing. 1 with 2. In fact, I didn't circle 2 here. 1 with 2. So again, times 4 times negative 3 to make them both 12s. 1 negative 12, 1 positive 12. So multiply 4 times 3, 4 times 5, 4 times negative z, 4 times negative 2. Then negative 3 times these guys gives you this result. The 12x's cancel. So I have 23y minus 10z equals negative 11. Then I did 1 with 3, which again, I didn't circle this one either. Not that it makes a huge difference, but 1 with 3. So I did these two. Notice that they're already opposite signs. But when you add them, something peculiar happens. All the variables cancel. On the left, they all cancel. On the right, you get negative 2. Now here is when all the variables cancel out and you have an equation that's never true. 0 never equals negative 2. So this means that no matter what you have, you're going to end up with something that does not make sense within the system. So this system has no result, no answer that's going to make all of these true at the same time. So there is no solution to this system. These are like pieces of paper. It could be that these pieces of paper are parallel, or they don't touch each other, or they don't intersect. This, on the previous problem, is where these three pieces of paper, what are called planes, meet. They all intersect at one point. In other words, this values satisfy all three equations at the same time. No such luck over here, so you have no answer. So whenever all the variables cancel and the right-hand side doesn't cancel, and you get something that's never true, this answer has no answer. So there's no plugging back because everything canceled out. The variables all cancel out. Okay. Now a case with a whole bunch of answers. There's other case where what happens if you actually get more than one answer? Well, you have your system. I do the same thing. 1 with 2. I try to cancel this x with that x. So I multiply the middle one by -2. In doing so, I get this result. And I add it to the first one. And notice that the x is canceled. As planned, so 3y minus 5z equals to 6. That's number 2. So now I do 1 with 3. So I multiply 2 times -2 to make -4 to cancel with the +4. So -4x, -2y plus 6z equals 0. So notice that it cancels. But the right-hand side is also 0. The 0 plus 0 becomes 0. So here, instead of getting 0 equals a different number, it's not 0, and it's number 2. This always works. This is always true. 0 is always equal to itself. So when the variables all cancel out, but we get an equation that it's always true, what's called a tautology, this has an infinite number of answers. It's not every single 3-number combination is going to work, but there's a whole bunch of an infinite number that are going to work. So what they do is this. They say, let z be an arbitrary value. And so they just say, you know what? Z is just z. So take this answer for z and go back and put into the second equation. So this equation, we're going to solve for y in terms of z. So I'm going to move everything to the right and get y by itself. So I added 5z to both sides. So 5z plus 6. And I divide everything by 3. So that is my value for y. Now it's in terms of z. So we're going to take that answer and we're going to put it back here. Back to the first. So y essentially, but instead of doing that right away, because it deals with fractions, I'm going to take the first equation and I'm going to move everything to the right. And I'm going to solve for z. So the first equation, I'm going to solve for x. Sorry, not solve for z, solve for x. So I subtract y, I added 3z. So on the right, I have 3z minus y. And now, instead of dividing by 2, I multiply by 1/2, putting this over 2. But essentially, y, I want to put back this in its place. So 3z minus 5z plus 6 over 3. Now, to get the common denominators, I have to multiply the top and the bottom by 3. So essentially here, this becomes 9z over 3 minus all this over 3. So now I can combine the like term. I can combine the denominators, one fraction, and so 9z minus 5z minus 6, which becomes 4z minus 6. Now essentially I can divide everything. I can multiply now across the fraction. So 2 times 3 on the bottom. So they all have a 2 in common. So I'm going to factor out a 2 out of here, a 2 out of here, and a 2 out of here, leaving me with 2z minus 3 over 3. This is the x value in terms of z. This is the y value in terms of z. And then z is just z. So your x, your y, and your z. This is so arbitrary. It says if z is equal to 1, you can plug these numbers in here and you can find x and y. So this all three are like a function of z. So like if z is -7, you can plug it here and here, get x and y. So it's a combination of of order triples depending on what you choose for z. Okay, so that essentially leads us to the end of 5.1.